Welcome back to my channel, and today we're going together solve the daily LeetCode problem. And so for our today problem, we have the problem of finding the smallest missing non-negative integer after some of the operations. And then so in here we can check like the operations like it means that like for a given array nums, and then for each value in the array, and then we can apply any number of times operations. Operation in here is that like we can add or subtract the given value in the num to the given value here. For example, like in here, like with given 1, we can freely add or subtract 5 from 1, but it is not the things like in here we can apply any number of times. However, like in here we have the like we have the conditions that we only care about the non-negative value. So it means that like for the negative value in here, it is better for us to just do the adding operation. Yeah, so in here, like if we perform a number of times, and then somehow like we will find the smallest missing non-negative integer after some of the operations. Yeah, so in here we can see that the sequence starts from 0 to 1 2 3 and 4 5, right? 6 7 8, and then so in here like we can see that the first missing value, that is the 4. So that is the reason why we return the 4 here. And then like if we apply the same logic, and then we can see that like the first missing value in the sequence in here is the 2, because like in here we have the by applying some of the operation, and then the array will be transformed to the 0 1 2, right? 2 is missing, and then that's why we return the 2. However, in here like we need some kind of the observation. For example, if we have any kind of the number, let's say that if we have the target number, and then this target is always can be described by x plus the k by the value. Okay, so so for example, if the target is the, for example, like in here, what if I have the, it means that in here like we are given the value, right? Let's say we apply the number 3 in here. Okay, so it means that this one is equal to 0, sorry, this one is equal to 3 plus 0 by the value, right? The value in here, that is the 5. Okay, how about the 8? 8 will be equal to the 3 plus 1 by the 5, right? So from here like we can have an observation. It means that like because we can see that this one is a k and this one is a k. So in here we are freely to choose the value of k. So as long as we have the number 3 in here, or 3, that is the modular, and then so we can construct the number 3 or number 8 by adding the any number of times, but like the k by the 5, right? Okay, so we still can construct 13 as well if we have the 3 in the array, and then we still can construct the 13. Why? Because like we have the 13 that is equal to the 3 plus 2 by 5, right? Okay, so based on these observations, and then somehow like we can come up with the solutions for our problem. And then to do this, and so because like in here we are working with the modular, right? And then with the modular, and then so for example, I will firstly transform this one into another array by, for example, we will get the 3 modular 5, and then this one is what is the 3, right? 0 modular 5 0, 3 modular 5 3, 2 4 2 1 1, and 10. How about 10? 10 modular 5 will be 0, and then we have the 4 again, right? Okay, so how can we find the smallest, like the max in here, minimum excluded number? Okay, so we just simply iterate from 0 to see that that number can be reconstructed by using the sequence of the numbers in here. Okay, so starting from the 0, okay, 0 can be constructed by using the 0 in here, right? Because that would be the 0 plus the 0 by the 5 in here, right? It means that we don't need to apply any kind of the number of the value, and it would be like itself. And the similar things will happen for the 2. It is 5, 2, that is 5. And then so 3, we have the 3, right? Okay, I will delete one of the number right after we uses, right? We use a 3, 2, right? Okay, and we also use the 1. Okay, so another number, that is the 4. Okay, it exists, right? And then we will delete one number 4 from here. Okay, so how about number 5? Can we construct the number 5? Yes, we can, because we have another the value 0 in here. So it means that like from 10 in here, we can minus 5 to get the 5, right? Okay, so we can construct this one from the 0. Okay, 5 is fine. And we will delete the 0 from here. Okay, so let's start with the 6. Okay, can we construct the 6? Yes, right? Because of what? Because 6, that modular to the 5, that is the 1. And then somehow like we just need to look for the 1 in the array. And that is what? That is the 1 plus 1 by 5, right? Okay, so we just need to find the modular of this number in the array. So fortunately we have that number here, right? We still have another one, so it means that like we can reconstruct the value 6 from this kind of the array, right? Okay, so in here 6 is fine, and then I will delete this one. Okay, so how about 7? How about 7? Is it possible to use to reconstruct the 7? Yes, because like we have the number 3 in we have the 2 in here. Because of what? Because 7, that is modular to 5, that is equal to 2. So it means that if we just have the number 2 in the array, and then we can reconstruct the 7. Okay, so it means that the 7 is fine. Okay, so for now we need to do with the things with the number 3, because like we reconstruct the number 8, right? And then so somehow we can see that like it is fine, because like 8 modular 5, that is the 3. So we can reconstruct the 8 from 3. Okay, so delete this one. Okay, so maybe we still can construct the 9, because we have the number 4 in here, right? With the similar logic, and then we will delete it. Okay, so it means that like, what is the 10? Okay, so we cannot construct the 10, because like in here we have no more the value 0, because 10 modular 5, that is a 0. So we don't have the 0 here. So it means that like we are unable to reconstruct the 10. Okay, so from here like we can see that like we can efficiently implement this one using the hash map or like the lookup table, right? And then we just based on the frequency. For example, in here we can see that the frequency of 3, that is the 2, right? And the frequency of 1, that is the 2. So in here we also have the frequency of 0, that is 2. So it means that like anytime we encounter the value of 0 in here, and then we will reduce the frequency of 0 to 1, right? We reduce it by 1, and then until we can see that like in here the value of 0, we will reduce it because we use it, and then in here we use another 1, right? And then the value of 0, I mean the frequency, that would be the 0, until we reach to the value of 10. And then somehow if we have no more value of 0 to reconstruct the value 10, and then it means that that is the first value we cannot reconstruct, and that is the minimum excluded number we expect to find. Okay, so let's program it together. Yeah, so firstly we just need to get the modular, and that would be equal to the num, and then we divide it, we get modular to the value for num in nums, right? And then after we have this array, and then we should do the things like we will have the hash map, and with this hash map, and then we will calculate the frequency of this one. However, like in here we have the built-in function that is the counter, and then it will help us to get the modular, right? So after this, and then we just simply let's say that like the minimum excluded number, that is the I, and then we will get that one will be iterated from the 0, and then while just say that y true, right? And then so here the num will be equal to the modular between the I and the value, and then somehow like we just need to check that if the num uh, in the hash map and the hash map of num greater than 0, and then we will reduce this by 1, right? Otherwise, and then also we need to increase this by 1, otherwise we just need to return the I, right? Because that is the first minimum excluded number. Okay, so just run it. Okay, so I think that most of people have the same solution as me. Yeah, so thank you so much for watching my video, and I hope that this explanation is useful for you guys to solve the today LeetCode problem. And yeah, again, thank you so much for watching my video, and see you next time.